Hello, myself is Kirungare, Department of Electrical Engineering, SMD College of Engineering and Research Center, Eola. I welcome you in video lecture series of Basic Electrical Engineering, which is a course of first year engineering. We are discussing on batteries. In last lecture, we discussed about the different types of the primary cells. Let us discuss with the secondary cells in part 3. So the nickel cadmium is one of the type of the secondary cell. The cell and batteries. This type of cells delivers high current. It can be recharged many times. So that is the benefit of nickel cadmium cell. It can be recharged number of times. It can be stored for long periods of time. Applications include portable power tools, alarm systems, portable radio and TV equipments. So for this we can use this nickel cadmium cell, and it provides the high current, and also storing capacity is more, and for a long period it stores the energy. The nickel cadmium cells and batteries. So the reaction for charging and discharging for this is like this: NiOH3 plus CD is discharge reaction. It gives 2 NiOH2 plus CdOH2, and it is reversible during charging. Chemical reaction is reversible. So the electrolyte is a potassium hydroxide, KOH, but does not appear above, as its function is to act as a conductor only for the transfer of the hydroxyl ions. Its specific gravity does not change with the state of the charge. So remember here, though in this battery KOH solution is used, but that is only for the conduction purpose. We transfer the ions. Its specific gravity does not change with the state of the charge. Next is the nickel metal hydride, the NiMH cells. These cells are used in applications demanding long-running battery performance. Example, high-end portable electrical or electronic products like power tools. In that, these nickel metal hydride cells are used. They offer 40% more capacity over a comparably sized nickel cadmium cell. So its capacity is about 40% more than that of the nickel cadmium. They contain the same components as nickel cadmium cells, except for a negative electrode. Negative electrode is different. So they are more expensive than nickel cadmium cells. Cells discharge more rapidly and cannot be cycled as frequently as NiCd cells. So its charging discharging cycles are not, the frequency is less than that of the NiCd cells. The nickel ion, it is also called as the Edison cells. These cells were once used in industrial truck and railway applications. They are now almost obsolete due to lead acid batteries. Lead acid batteries के use के कारण they are now almost obsolete. Nickel zinc cells. These cells were previously used in some railway applications. Their high energy density created interest in their applications to electric cars also. They have limited life cycles for charging. That is the disadvantage of this cell. The next type of cylinder cell is the fuel cell. The fuel cell is an electrochemical device that converts chemicals such as hydrogen and oxygen into water and produces electricity in the process. So as long as the reactants, hydrogen and oxygen, are supplied to the fuel cells, it will continuously produce electricity and never go dead, unlike conventional batteries. So as long as it gives hydrogen and oxygen, they are continuously can be in working condition. The fuel cells using methanol and oxygen are being developed. Fuel cells are used extensively in the space program as sources of DC power. Space program में fuel cells का use होता है. They are very efficient, capable of providing hundreds of kilowatts of power. So why they are being used? Because they are very efficient and capable of providing hundreds of kilowatts of power. The next type of cell is the solar cell. Solar cells convert the solar energy, the light energy, into electric energy. They are made of semiconductor materials. They are arranged in modules that are assembled into a large solar array to produce the required power. The photovoltaic cells are there in the solar cells, and that photovoltaic cells are connected in series and parallel combinations to enhance the voltage and current capacity. An applied voltage higher than the voltage of one cell can be obtained by connecting cells in series. The total voltage available across the battery of cells is equal to the sum of the individual values for each cell. Parallel cells have the same voltage as one cell but have more current capacity. So in parallel combination, we enhance the current capacity. In series connection, we enhance the voltage capacity. So to provide a higher output voltage and more current capacity, cells can be connected in series parallel combination. So there is the array of series and parallel combination of photovoltaic cells in the solar panels. The combinations of cells is called the battery. So the combinations of series and parallel connected cells is like this. This is cell 1, cell 2 and cell 3. These are connected in series, and across terminal A and B will get the sum of all the individual battery or cell voltages, the 1.5 plus 1.5 plus 1.5, and the voltage across these three series combination combined cells will be 4.5 volt. But the current through them remains same. So their equivalent circuit, electrical circuit is this like this. This first battery, second and third one are connected in series, and their equivalent across terminal A and B will be 4.5 volt. Okay, so this is the equivalent battery voltage. The current capacity of the battery with cells in series is the same as that for one cell, because the same current flows through all the series combination. So like this, it can be combined. The equivalent battery can be combined across these two terminals or across this load resistance for use. Here these three batteries are connected in parallel. So cell 1, cell 2 and cell 3 of magnitude 1.5 volt each. They are connected in parallel. Now here the voltage remains same. Voltage in equivalent will remain same as 1.5 volt, but the current capacity increases. The current capacity of this will be increased because they are in parallel. So this is their equivalent parallel combination circuit of the cells. So you will get at the end the individual voltage cell voltage is 1.5 volt. That you can connect across this load resistor, and the current through this is enhanced, and it is up to 50 milliamp. So here series and parallel combination, again these are the two sets of series connected batteries. Cell 1 and 2 are in series, cell 3 and cell 4 are again in series, and these two series combinations is connected parallelly. So this is series parallel combination, and here voltage as well as current capacity enhance or increases. So you will get the voltage as 3 volt, and the current also get increased here. To provide higher output voltage and more current capacity, cells can be connected in series parallel combination. So this is the equivalent circuit for this previous diagram. 3 volt, 3 volt. This series of two cells. This is series combination of 2 volt, 2 cells, 3 volt, 3 volt. They are connected in parallel. So at the output, we will get the 3 volt, and the current capacity of this will be 100 milliamp. Because this is 50 milliamp, this is 50 milliamp, and the total will be 100 milliamp. Like this, you will get the current and voltage increase. So current drain depends on the load resistance. Whatever the battery capacity, whatever it may be, the drain of current depends on the load resistance. So it is important to know the current rating of batteries for any voltage source. It is only a guide to typical values permissible for normal service life. So the actual amount of the current produced when the battery is connected to a load resistance is equal to I is equal to V upon R. So the current value, the maximum current rating is there, but time to time, at a particular instant of time, the battery will provide the current, and that depends on the value of the load resistance, how much load you are connected, and that instantaneous value of the current will be V upon R. So here load is connected. Okay, here load of 7.5 ohm, then load of 150 ohm, then load of 2.5 ohm. So for every the same battery is connected, right? But the current delivered or drain is different for this different value of the load resistance. In first case, it is I is V upon R1, that is V is your 1.5 upon R1 is 7.5 ohm. Okay, so you will get the current as 200 milliamp. Here you will get the current 10 milliamp. Here you will get the current as 600 milliamp. So your current depends on the load resistor. So cell delivers less current with higher resistance in the load circuit. A cell can deliver a smaller load current for a longer time. Now the internal resistance of a generator. A generator is any source that produces continuous voltage output. The internal resistance Ri causes the output voltage of a generator to drop as the amount of current increases. All generators have their internal resistances. Now matching the load resistance to the internal resistance of the generator that causes the maximum power transfer from generator to the load. Here for measuring internal resistance, Ri is equal to, okay, 12 volt battery is there, generator, here its internal resistance is 0.01 and the load resistance is connected there. So here you will get the Ri is equal to VNL minus VL, that is 12 minus 11.9 upon 10, and that is 0.01. That is the internal resistance. So thank you. Next time we'll discuss about the next topic in the batteries.